This presentation explains APTEX valve porting. An open triangle means flow enters into the valve below the seat. This is an inlet port. Two opposing triangles is two common ports connected below the valve seat. A solid triangle is an outlet port. This port is downstream the seat. Two solid triangles is two common ports downstream the seat, passing through the diaphragm cavity. A two-ported valve symbol is two opposing triangles. One triangle is open. This is the inlet port. The port enters the valve below the seat. The other triangle is solid. This port is downstream of the seat. This is a standard two-port on-off valve symbol. These are three images, each showing the same 2PW valve with the same porting. The plan view on the left is a view from the top of the valve looking from the actuator side. The gas enters from the inlet, port 1, and exits through the outlet, port 2. The center circle is the seat cavity. The smaller circle to the left is the outlet port. The two circles with dotted lines in the corners are mounting holes on the bottom of the valve. Arrow number 1 flows to the seat cavity. The outlet port flows to arrow number 2. The schematic in the middle shows inlet port 1, an open triangle, and the outlet port 2, a solid triangle. The sectional view drawing on the right has an open triangle representing a port entering the valve below the seat, and a solid triangle representing an outlet port exiting the valve downstream of the seat. All images share the same valve porting. Even though this valve is shown in its normal flow direction, bidirectional flow is common for diaphragm valves up to their full rated pressures. Three triangles is a three-port valve. The image on the left is a valve with two inlet and one outlet ports. The two inlet ports, the open triangles, are common. Gas flows through if the valve is open or closed. When the valve is closed, the solid triangle outlet port is shut off. When the valve is opened, gas flows through the outlet port. The 3PWD port configuration is shown here in three different images: plan view, three-port schematic view, and two-port valve with an equivalent schematic view. 3PWD is one of the optional three-port valve configurations. Note how the 3PWD porting eliminates a plumbing T. 3- and 4-port valve configurations can be used to eliminate plumbing Ts and elbows. Look at the image on the left. This is a plan view from the actuator side of the valve looking down. Notice the three solid arrows. An arrow pointing towards the valve indicates inlet ports. Ports 1 and 3 are inlet ports. An arrow pointing away from the valve indicates an outlet port. Port 2 is an outlet port. Gas will flow through the two inlets if the valve is open or closed. There are 5 circles in the square. The large circle is the diaphragm chamber. The circle in the middle is the valve seat. The circle below the seat is a passage to the outlet port 2. The two circles in the bottom left-hand corner and top right-hand corner are the valve mounting holes. The image in the center is a 3PWD schematic. Notice ports 1 and 3 are open triangles indicating inlet ports. The solid triangle, port 2, is the outlet port. The image on the right is a two-ported valve schematic equivalent of the 3PWD. There are two inlets, ports 1 and 3. They tee into the valve inlet port, the empty triangle. The gas exits the valve through the outlet port 2, the solid triangle. Ports 1 and 3 enter the valve below the seat, and port 2 exits the valve downstream of the seat. Now let's look at the 3PWD configuration from the sectional cutting plane views and a plan view. Recall the 3PWD body has two inlet ports flowing through the body and one outlet port opposite the inlet ports, eliminating a T in the plumbing. The plan view is cut into section AA and section BB cutting planes. The section BB cutting plane view shows the outlet port exiting the valve on the right downstream of the seat. The section AA cutting plane view shows the inlet ports passing through the body below the seat. Product note number 443 is available online at aptech-online.com. This document defines all available porting configurations by name, plan view, and 2 schematic views, including the 2-ported valve equivalent. This document applies to most 1/4 and 3/8 inch valves, meaning most 3 series and 4 series valves. A customer's piping system diagram may use arrows or triangles to indicate the flow direction, not the type of valve port. Be very careful to distinguish between P&ID flow direction and APTech inlet and outlet ports, as this is where most mistakes are made. In the top diagram, a customer's P&ID indicates flow direction with arrows. Gas flows through the valve under the seat from left to right and exits port number 3. However, in the bottom diagram, APTech porting under the seat is always an inlet, even if the flow direction of port number 3 is in fact reversed. Now let's configure valve porting for a section of a valve manifold box, or VMB, inside this red square. These pneumatic valves are AP3540s. The tubing is 1/4 inch. The flow schematic represents the valve porting inside the red square and the 2-ported valve equivalent. The 3-ported pneumatic 3540, located at the bottom, has a 1/4 inch female face seal inlet port at 9 o'clock and a tube stub at 3 o'clock. This valve's outlet port at 12 o'clock flows to the 4-ported pneumatic valve. Located at the top of the red square, this 4-ported pneumatic valve's process gas enters the valve's inlet at 6 o'clock and flows through the valve under the seat to the 1/4 inch male face seal fitting. The outlet ports are 1/4 inch female face seal at 9 o'clock and the 1/4 inch tube stub located at 3 o'clock. When this valve opens, purge gas flows from the 1/4 inch female face seal to the 1/4 inch male face seal port located at 12 o'clock and the tube stub at 6 o'clock. This is a common example of a valve being used in a reverse flow direction from standard. In the example, the outlet ports are being used as inlet ports and the inlet ports as outlet ports. Most APTech 1/4 and 3/8 inch valves can be used in reverse flow. Some applications use reverse port flow to minimize unswept or wetted volumes, such as this example. The 3-ported valve with 2 inlets and 1 outlet is a 3540 valve. The inlet port is 1/4 inch female face seal and flows through the body under the seat to the other inlet port with a 1/4 inch tube stub. The outlet port is opposite the inlet ports and is downstream of the seat. This is a 3 PWD flow pattern, which we reviewed prior. When configuring the part number, the ports are specified in sequential order, starting with port number 1. The part number is AP3540S 3 PWD FV4 TW4 TW4. Now let's configure the 4-ported valve. It's also a 3540. The gas flows through ports number 1 and 3. These are inlet ports. Port number 1 is a 1/4 inch tube stub. Port number 3 is 1/4 inch male face seal. Ports number 2 and 4 are outlet ports downstream of the valve seat. Port number 2 is a 1/4 inch female face seal. Port number 4 is 1/4 inch tube stub. Looking at APTech's product note number 443, a 4-ported valve with 2 inlet ports and 2 outlet ports opposite is a 4 PWM flow pattern. Again, when configuring the part number, the ports are specified in sequential order, starting with port number 1. So the part number is AP3540S 4 PWM TW4 FV4 MV4 TW4. APTech also offers the DV series of monoblock valves with configurable porting options. See Technical Bulletin number 205B on our website for more information. APTech's half-inch valves have different porting configurations, including purge ports. Purge ports are an inlet or an outlet port either upstream of the seat or downstream of the seat. See the AP37 datasheet for port configuration options. For more information about APTech products and technical resources, please go to aptech-online.com.